So hello guys, welcome to this video where we'll be discussing an RL circuit problem. So before we dive into the problem and the video, let's just give a brief introduction of myself. I am Saptarshi Mondal of Power Engineering Department, first year from Jadavpur University. My roll number is 002511501036, but you can already see that on the screen. This is the part of a winter assignment or a special assignment given to us by our PRP sir of Basic Electrical Engineering subject under the AC Fundamentals chapter. And I guess that's all about the introduction. So let's just dive into the question now. So that's the RL circuit problem. The problem statement is a RL CD circuit is connected to an AC voltage supply of 200 volts, which is the RMS value, of course, with a frequency of 50 hertz. The resistor has a value of 40 ohm and the inductor has a value of 40 Henry. We are asked to calculate the inductive reactance, the total impedance, the current to the AC circuit, the phase angle between the RMS voltage and the RMS current. So let's just first see the diagram. It will be a basic diagram since it's a basic circuit of just C's, R and L. So this will be the diagram. It's not of much of importance in this question. So let's just dive into the question. And the first part of solving a question is to write down the given quantities in the question, the problem statement. So we will first do that. So the given quantities are as follows. The resistance, which is denoted by R, is 40 ohm. The inductance, symbolized by L, is 40 Henry. The voltage, the RMS voltage, which is denoted by VRMS, is 200 volts. And the frequency of the signal, F, is 50 hertz. So that's all about the given section, and now we will dive into, you can guess it, the step-by-step solution. So let's just skip, and there we are. uh, we know that inductive reactance, which is denoted by XL, is 2 into pi FL, where 2 is a constant, of course, pi is also a constant, 3.14 something something. F is given in the question, the frequency of the signal, and L is also given in the question as inductance. So since we know all the values, we'll just plug in them, and plugging in all the values, we get XL equals to 2 into pi into 50 into 40, which gives us a value of 12,566.37 ohm. So that gives the answer of the first question. As inductive reactance is 12,566.37 ohm. So let's just now go to the second question, the total impedance, and the total impedance is denoted by Z, and the formula of that is root over R square plus XL square, where R is the react resistance and XL is the inductive reactance. We know from one from the given part and one from the just recently derived part in the answer. So XL. So we will just do that, and 40 square plus 12566.37 square, and do the root of the whole thing, and we will get the answer as 12566.43 ohm. So that gives us the answer of the second question, that is, thus total impedance is 12566.43 ohm. I guess I have no space left in this slide, so I'll just go to the next slide. From the previous slide, we know that XL is 12566.37 ohm and Z is 12566.43 ohm, where XL is the inductive reactance and Z is the total impedance. Now the two questions remaining were the current through the AC circuit and the phase angle between VRMS and IRMS. So now we'll do the current, and to find out the current, we know that current is always the voltage by resistance. Here the resistance is the resistance of the resistor plus the resistance provided by the inductor, so it will be the impedance, the total impedance. So the formula will be the current through the circuit, which is IRMS. The RMS value is VRMS by the total impedance, or Z, which is 200 by 12566.43, which will come out to an approximate value of 0.016 ampere. So that gives the answer of the third question. So the thus current through the circuit is 0.016 ampere. We are almost done, given all we are on the last question. The last question is the phase angle question. So for that, we need to draw the phasor diagram. So let's just draw the phasor diagram. Since this is a series circuit, the current is not divided, and since it's in the undivided part, we will take that as the reference. So IRMS is the reference, and as we know, that reference is always taken along the x-axis for our convenience. So we'll first draw the IRMS along the x-axis, that is like this, and then we will move into drawing the VR. VR is the voltage across the resistance, and from a purely resistive circuit, we know that the phase angle difference between VRMS and that VRMS, uh, I mean, which will here be the VR, and that there will be VRMS, and the IRMS is zero. So it lies with the same phase, so it will be along x-axis as well. So here VR, which is the voltage along the across the react resistor, which is VR, is along the x-axis as well, and it's noted by VR. And here's a definition of VR, voltage across the resistance, VIR, and the formula for finding that is IRMS into R. So that's halfway there. We will now find out the VL. So from a purely inductive circuit, we know that the the voltage of that circuit leads the current by a phase angle of 90. So VL will be up here, upwards. So with an angle of 90 degree or pi by 2 radians, and this is VL, where VL is the voltage across the inductor, and the formula for finding that is VIRMS into XL, the inductive reactance. Now we need to draw the VRMS now, and we know that VRMS is the resultant of VL and VR, so it will be like this down the middle. This is the VRMS, and now the question is the phase angle between VRMS and IRMS. We know the VRMS, we know the IRMS. Now this angle, which will be denoted by delta here, is the phase angle which we need to find. So we can just shift this VL towards right and draw a triangle, right angle triangle, and from that triangle we can know. So delta is the phase angle between VRS and IRMS, and now we will use that triangle to solve the question. So from the given diagram, we can say tan delta is VL by VR. You can see that properly. And now we will simplify this by the given values of VL and VR. VL can be simplified that, sorry, what is this? Uh, VL can be simplified as IRMS into XL, and VR can be simplified as IRMS into R. Now we can cancel out the IRMS and write it as XL by R, and we know the value of XL and R, which is 12566.37 by 40, which gives us a value of 314.16. So that is the value of 10 tan delta. So tan delta is 314.16, and delta will be tan inverse of 314.16, which gives us an approximate value of 89.82 degrees. So that gives the answer of the last question, which will be, thus the phase angle between the RMS voltage and the RMS current is 89.82 degrees. That is, VRMS leads IRMS by an angle of 89.82 degrees. So that's all about it. The question, it's over. Thank you for watching, and